At 1600 Amphitheater Parkway in California sits Google's iconic headquarters. But the thousands of engineers walking those halls didn't build it. They are working inside the $7 billion graveyard of a forgotten company that invented the modern digital world, gave it away for free, and accidentally destroyed itself in the process. To understand how an empire evaporates, you have to understand how it was built. And this one began with a high school dropout from a farming town in West Texas. James Clark was born in 1944 in a place where ambition was generally measured in acres of dirt, not patents. By 16, he had dropped out of school entirely. He was suspended for setting off a smoke bomb on a school bus, an early indicator of a mind that liked to see how things reacted when pushed. He joined the United States Navy, spent 4 years in uniform, and somewhere along the line, someone handed him an electronics manual. Something in the circuitry clicked. Clark didn't just read the manual, he absorbed the logic of it. He began taking night courses at Tulane University, quietly sitting in lecture halls without a high school diploma, and quickly discovered an uncomfortable truth. He could outwork and outthink almost anyone in the room. He earned a bachelor's degree, then a master's in physics, then a PhD in computer science from the University of Utah legendary department that was quietly incubating the future founders of Pixar, Adobe, and Atari. By the late 1970s, James Clark found himself standing at the front of a classroom as an associate professor of electrical engineering at Stanford University, and he was obsessed with a problem that the rest of the computing world was actively ignoring. At the time, three-dimensional computer graphics were practically science fiction. If an automotive engineer wanted to rotate a digital prototype of a car chassis, or a chemist wanted to spin a molecule on a screen to see how it bonded, they couldn't just open a laptop. They had a runtime on massive room-sized mainframe computers that cost upward of $250,000. Rendering a 3D object requires an enormous amount of continuous, brutal mathematics. Every time you move the camera, the computer has to recalculate the geometry of every single polygon on the screen in real time. Processors in the 1970s simply choked on that kind of math. Clark looked at these massive $250,000 mainframes and decided he wanted to put that exact capability into a box that could sit on an ordinary desk. By 1981, Clark and his graduate students had done the impossible. They had taken the massive sprawling mathematical workload required to render 3D space and hard-coded it directly into the silicon of a single microchip. They called it the geometry engine. Clark designed it under an ARPA contract alongside a brilliant graduate student named Mark Hanna. Hanna was a black electrical engineer who had come out west from the Illinois Institute of Technology, and together, they built a foundational piece of the modern world. The geometry engine was the first chip of its kind of hardware accelerator, entirely dedicated to the geometry calculations required to render three-dimensional images. Clark immediately patented it. He knew exactly what he was holding. This wasn't just a research paper. This was a company. In 1982, Clark, Hanna, and a core team of 6 other graduate students walked away from Stanford. Armed with venture capital from the Mayfield Fund, they founded a company called Silicon Graphics. But Clark was remarkably self-aware. He knew he was a visionary, a builder, and a notoriously difficult personality. He was not a corporate manager. To keep the company from imploding on day one, he brought in a seasoned veteran from Hewlett-Packard named Ed McCracken to serve as CEO. In 1983, Silicon Graphics shipped its first product, the IRIX 1000 graphics terminal. The first unit went to Carnegie Mellon University. And then, almost nothing happened. For half a decade, Silicon Graphics wandered through the desert. As Clark later recalled, they were out preaching the gospel of 3D graphics. But very few people were ready to be converted. The IRIX terminals were highly specialized, expensive niche machines. They were incredible tools, but their customer base was limited to structural engineers testing architectural loads and scientists modeling chemical compounds. The only reason Silicon Graphics survived these lean early years was because the undisputed giants of the computing world, IBM, Sun Microsystems, and Hewlett-Packard were moving too slowly. They didn't view 3D graphics as a serious market. They left the field entirely uncontested, allowing Silicon Graphics to quietly dominate a tiny corner of the industry. By 1986, the year the company went public, they were pulling in $40 million in revenue. It was a respectable, solid business. But a respectable business doesn't build a $7 billion empire. To do that, Silicon Graphics needed to stop selling to scientists and start selling to storytellers. In 1984, Silicon Graphics made a quiet, strategic move that would fundamentally alter the trajectory of human entertainment. They packed up a prototype workstation, drove it out of Mountain View, and handed it over free of charge to a filmmaker named George Lucas. Industrial Light and Magic, Lucas's legendary special effects house, booted up the machine. They were instantly mesmerized. They started buying SGI hardware in bulk. Back in Mountain View, Mark Hanna, who was now serving as SGI's principal scientist, started writing the complex visual graphics programs that would soon render the most ambitious visual effects in Hollywood history. The liquid metal morphing sequences in Terminator 2, the dancing objects in Disney's Beauty and the Beast, the glowing, treacherous cave of wonders in Aladdin. If you read the mainstream histories of Silicon Graphics, James Clark usually gets the spotlight as the brilliant founder, but it was Mark Hanna who was quietly building the visual engine underneath the hood that made the magic possible. By 1991, the bridge between Silicon Valley and Hollywood was completely forged, and that July Silicon Graphics released a machine so powerful, so perfectly engineered, that it was actually codenamed Hollywood during development. They called it the IRIX Indigo. Priced at just under $8,000, it was a dark blue, 25-pound box compact, enough to sit neatly on a single desk. But inside, it was a monster. It ran a blistering 64-bit MIPS processor, paired with hardware-accelerated 3D rendering that absolutely nothing else on the market could touch for the price. Instead of the jarring, mechanical beep that most computers made when turned on, the Indigo greeted its user with a smooth, polite musical chord. It was a masterpiece of industrial and electronic design. A reviewer at the time called it the most promising product launch in years. The graphics architecture that made the Indigo possible was designed by Kurt Ake, an original co-founder who had been wiring the nervous system of SGI machines since the very beginning. The Indigo pushed Silicon Graphics into the Fortune 500. But the desktop was just the beginning. While the Indigo sat on desks, SGI also built the Onyx. The Onyx was not a desktop computer. It was a refrigerator-sized visualization supercomputer running Akeley's crowning achievement, the Reality Engine. It was designed to manage multiple, impossibly complex streams of fully realized 3D graphics simultaneously. Industrial Light and Magic bought them by the roomful. In 1993, Steven Spielberg released Jurassic Park, and the film industry changed overnight. ILM had used more than 70 Silicon Graphics workstations to generate the film's terrifyingly realistic digital dinosaurs. The machines were so integral to the production that Spielberg actually put one in the movie. When Samuel L. Jackson is sitting in the park's control room, the dark box sitting on the desk behind him isn't a prop. It's a real SGI workstation. Later in the film, the famous scene where a character navigates a three-dimensional file system to reboot the park's security, that wasn't fake Hollywood interface design. That was IRIX Silicon Graphics' actual operating system. The Onyx had proved something profound. A computer could now generate imagery realistic enough to completely replace physical reality on a movie screen. SGI hardware rendered Forrest Gump. It rendered The Mask. In 1995, Toy Story became the first entirely computer-generated feature film in history, and every single frame was rendered on Silicon Graphics machines. From 1995 to 2002, every single film nominated for an Academy Award for Best Visual Effects used SGI systems, and they didn't stop at the box office. In 1993, SGI signed a massive deal with Nintendo. A brilliant engineer named Wei Yen led a team in Mountain View to design a custom reality coprocessor. In 1996, that chip shipped inside the Nintendo 64. Suddenly, the same company rendering Hollywood blockbusters was putting 3D graphics into the living rooms of million kids for under $250. Under CEO Ed McCracken, SGI's annual revenue exploded from $5 million to $3.7 billion. Their market capitalization peaked at over $7 billion. They employed 10,000 people. They were untouchable. But hidden inside this golden age was a ticking time bomb. And the tragedy is, Silicon Graphics built the bomb themselves. Let's rewind to 1992, right as SGI was entering its period of absolute dominance. Kurt Akeley and his engineering team made a decision that would echo through the technology sector for the next 30 years. Up until this point, if you wanted to write software that used SGI's hardware acceleration, you had to use their proprietary graphics library called IRIX-GL. It was locked down. It belonged to them. But Akeley's team looked at the broader industry and realized that closed systems eventually stifle innovation. So, they did something unprecedented. They took their proprietary, world-class graphics library, cleaned up the code, stripped out the SGI-specific quirks, and opened it up to their competitors for a minimal licensing fee. They renamed it OpenGL. For the first time in computing history, any hardware manufacturer could write fast, efficient, cross-platform 3D graphics, using the exact same standard that Silicon Graphics had spent a decade perfecting for itself. There are two ways to view this decision. An honest history requires holding both of them in your head at the exact same time. On one hand, it was a brilliantly generous, far-sighted move. It made 3D graphics universal. It cemented Silicon Graphics as the foundational architect of the modern visual world. On the other hand, it was corporate suicide. By releasing OpenGL, Silicon Graphics had just handed every scrappy, hungry competitor on Earth the exact tools they needed to build cheaper, stripped-down alternatives. SGI had spent a decade building a moat around their castle. With OpenGL, they lowered the drawbridge and handed out maps to the armory. By January of 1994, James Clark, the man who started it all, was looking closely at the horizon. Clark was a restless visionary, and what he saw terrified him. He looked at the massive, expensive workstations his company was building, and he realized the paradigm was shifting. The future of human computing wasn't going to be isolated. High-end visualization, supercomputing. The future was going to be thousands of computers talking to each other over telephone lines. The future was the internet. Clark tried to pivot the company, but SGI was making too much money selling hardware to Hollywood to listen. So, Clark did what he always did. He walked. He resigned as chairman, leaving behind roughly 400,000 shares of SGI stock. Within a matter of weeks, he partnered with a young programmer named Mark Andreessen and co-founded Netscape, launching the commercial web browser revolution. The company Clark left behind was about to learn just how right he was. By the mid-1990s, the trap that SGI had set for itself with OpenGL sprang shut. Commodity personal computers as standard, beige boxers running Windows were suddenly getting dangerously powerful. Startups with names like NVIDIA and ATI began producing cheap graphics cards that could plug right into a normal PC. These cards were hitting rendering speeds that approached SGI's massive workstations, but at 1/10 of the cost. And this wasn't a coincidence. Many of the lead engineers designing those cheap PC graphics cards were former SGI employees who had simply walked out of the Mountain View offices, carrying a decade of institutional knowledge in their heads. The final lock on SGI's monopoly broke in 1995. SGI had acquired the companies behind Maya, the industry-standard 3D animation software, for $500 million. But soon, Maya was ported to run on Linux, Windows, and Mac, the invisible wall protecting SGI, a visual effects studio that previously had no choice but to buy 100,000. SGI Onyx could now walk into a standard electronics store, buy a stack of cheap Windows PCs, link them together into a render farm, and do the exact same job for a fraction of the cost. SGI was bleeding, and their reaction to the crisis turned a slow decline into a fatal nosedive. When a massive tech company starts losing its monopoly, panic usually sets in the executive suite. In 1997, CEO Ed McCracken was fired.
Desperate to reinvent themselves, the new leadership made two catastrophic bets. First, they looked at the processors powering their machines. For years, SGI had relied on the MIPS architecture, a highly efficient, custom processor that their entire software ecosystem was built around.
But Intel had just announced a revolutionary new chip called Onyx, promising unheard-of performance. SGI took the bait. They announced they were abandoning their proprietary MIPS architecture to commit their entire future to Intel's. It was a disaster of historic proportions. The Onyx chip was brutally delayed. When it finally arrived, it severely underperformed its promises. By switching architectures, SGI forced its fiercely loyal customers into a dead end, stranding years of custom software development. SGI had essentially told their biggest clients to wait for a miracle that never arrived. While the core hardware business was imploding, leadership placed their second bet. In 1996, they spent roughly $740 million to acquire Cray Research, the legendary supercomputer manufacturer. It was the worst possible time to buy a supercomputer company. With the Cold War over, defense and energy departments, the primary buyers of supercomputers were actively slashing their research budgets. The market was contracting violently. SGI had placed two wildly expensive bets in opposite directions, and lost both. What followed was value destruction rendered in sheer, brutal arithmetic. In 1995, Silicon Graphics was worth over $7 billion. By November of 2005, its market capitalization had vaporized down to $120 million. The New York Stock Exchange delisted them. The empire had fallen. In May of 2006, Silicon Graphics filed for Chapter 11 bankruptcy protection. The dismantling of the giant was methodical and quiet. They emerged from bankruptcy in October, but they were a shell of their former selves. They packed up their sprawling, beautiful campus at Amphitheater Parkway in Mountain View and sold it to a rapidly growing search engine company that had been leasing office space there since 2003. Google bought the Silicon Graphics campus for $319 million. The rest of SGI was carved up and sold for parts. The legendary Cray brand was auctioned off to Terra Computer for $35 million. Their software division went for $57 million. The MIPS processor line and the beloved IRIX operating system were simply discontinued, abandoned to history. In April of 2009, SGI filed for bankruptcy a second time. The absolute final remnants of the company were sold to Rackable Systems for a paltry $25 million, eventually finalized at $42.5 million. The stockholders received absolutely nothing. Rackable took the SGI name, wearing it like a hollow suit of armor. In 2016, Hewlett-Packard Enterprise absorbed that remaining entity for $275 million. The $7 billion titan that rendered the dinosaurs was broken apart, passed around, and folded into larger corporate spreadsheets until nothing remained but a portfolio of patents and a borrowed name. But if you look closely, the empire never actually died. It just became invisible. The machines survived. Today, there is a fierce, dedicated underground community of collectors and engineers who still run Indigo. They swap spare parts across continents, carefully loading discontinued IRIX software onto hardware that shipped before some of its new owners were even born. They maintained these workstations decades after the company ended support, simply because the engineering inside them refuses to become irrelevant. The software survived, too. OpenGL, the standard SGI, generously and fatally gave away to the world evolved. Its specification became the direct ancestor of Vulkan, the high-performance graphics standard that currently runs on billions of devices worldwide. And Wei Yan's team, the engineers who built the Nintendo 64 chip inside When Yan left the company in 1997, he took 20 engineers with him and founded ART. They designed the graphics chip for the Nintendo GameCube. In 2000, ATI bought Artex for $400 million. That means the specific engineering lineage of Silicon Graphics runs directly through every Nintendo console that followed, straight through ATI, straight through AMD, and into the GPU inside the device you are using to watch this video right now. The company is gone, but its engineering is everywhere. If you visit 1600 Amphitheater Parkway today, the low buildings and bicycle paths look much the same. There is a massive dinosaur skeleton standing on the Google campus. Some engineers say it's a quiet nod to Jurassic Park, a tribute to the machines that first brought digital dinosaurs to life in that exact office park. Google has never officially confirmed this. What is confirmed is this. The campus, built to house the most dominant visual graphics company on Earth, now houses a company dedicated to indexing the world's text. The SGI logo came down. The Google logo went up. The hardware is gone. The stock is worthless, and the name belongs to a server conglomerate. But the standard they built is in your pocket, in your living room, and in every frame of every film that renders a world that does not exist. Silicon Graphics did not lose the 3D graphics market. They created the market, opened the door, and the entire world walked through without looking back. If you were there, if you ever rendered a model on an Indigo, or coded on a refrigerator-sized Onyx, if you walked the amphitheater campus, or if you just managed to load IRIX onto a machine you found at a surplus sale drop, a comment below. Tell us the exact model, the year, and whether it still boots up today. The engineers who built these machines and the artists who pushed them to the breaking point know vastly more about what was lost than the massive corporations that bought the scraps. Subscribe to the channel, because building this archive is how these stories survive. We have the breakdown of another American tech empire coming next, and you will not want to miss how the schematic ends.